Well, I'm going to talk about some new work we're launching, and it'll really take effect next year when we really begin the work to create measures for DevOps pipelines. I mean, most companies have adopted Agile, and most of them, or many of them at least, are starting to build DevOps pipelines and integrate the development activity with the operational deployment of systems and create teams around cross-functional relationships between development folks and operational folks to speed the ability to get functionality into live business activity. And the question is, how do we measure this? Because it is going to evolve the way we look at software measurement. Once we go into a DevOps pipeline, it really invites us to adopt a lot of the concepts that have emerged out of lean manufacturing and other areas of lean applications, and use these to talk about the ability to move from a request to actually having that implemented and available to the business and out in actual use. So I'm going to talk a bit about our activity. There is a new ISO working group focused on looking at measures for DevOps. Those tend to work a lot slower than CISQ does. So we intend to at least get something available and take it down to the actual implementation level as close as we can get it, and certainly at least have a framework for thinking about how to measure productivity, quality, efficiency, a number of other things within an integrated DevOps environment. Next slide, Tracy. So, there's lots of ways to visually represent the DevOps process. There's a typical one used. And when we look at this, it really drives a whole different thinking about how to measure our activity within this environment. First, there's now a move to a value chain philosophy. It's not just that I produce software and handed it over. It's that there's really a value chain from when I commit to executing a set of requirements all the way to when that is actually operating in the business. And so business outcome measures become the arbiters of whether I'm effective or not. We're now looking at flow measures. It opens up this whole concept that comes out of lean of the flow, the cycle time of the entire flow process, waiting time as ways to waste, really waste trying to get things through that pipeline. It changes the nature of productivity. We'll show you more about that in a second. But it also, in the DevOps world, forces us to think about how does the architecture of the product affect the efficiency of the flow down the pipeline. What do we have to do to optimize our ability to flow capability and new features down the pipeline? And are there blockages that we need to go solve? In fact, I heard an expert in the test process say frequently that's a huge blockage in the DevOps pipeline. And then how do we integrate local measures at different points in the pipeline into an ability across the overall activity to predict the business outcomes that we're going to get? So this is sort of the background for thinking about DevOps measurement. A lot of people are using DevOps as a follow-on to their attempt to adopt Agile methods. And some have adopted Agile more effectively than others. We hear a lot of executives complain that they think their Agile folks are not really adopting the discipline that's required. In fact, in almost any area of human activity, the shorter the time scale for doing something, the more that discipline is absolutely necessary, and process is critical. You don't have time to try to be figuring out what to do, and you don't have time to be fixing lots of mistakes. So truly, Agile done well requires more discipline than the old waterfall did because of the shortened time scale. I think Agile is going to get subsumed in the DevOps world, and what's going to be taken from Agile that's really valuable is the short cycle times, in essence, small batch sizes flowing down the pipeline, and a continual measurement that you get in a truly agile environment where you're able to measure quality, effectiveness, whatnot at various points along the way so that you can make quick adjustments when necessary rather than wait to the end point and then just have a buildup of a lot of problems. Next slide. So let's think about how we measure the pipeline. There's the development activity, the operations activity, there's a business outcome. Traditionally, we've talked about productivity in software as being some measure of how much product I produced divided by the number of hours that it took me to produce it, or person days or person years or whatever my denominator is. And that was our traditional measure of how productive we are. Next, Tracy. But now in a DevOps environment, really the measure of productivity has to be what did it take to get this feature down the entire pipeline and into business use. And so I will look at effort across the entire development and operational effort. And then how much stuff was delivered, and cycle time also becomes fairly critical when we want to look at efficiency. And frankly, the business cares about two things. What's the cycle time? Now, how long did it take from the time you committed to do it till I have it in use in my business? And two, what's the level of quality so that this thing doesn't crash or let hackers exploit it or degrade the performance or what have you. So that's what they care about. Productivity is not as critical except for cost. What's it costing me to do this? And so we really need to look at effort across the whole pipeline and what that compares to in terms of the amount of functionality being delivered into business operations. So next, Tracy. And so business productivity may become the ultimate arbiter here. What's our cycle time, but how is that helping the business increase its agility or increase its competitiveness and ultimately increase its revenue or its customer loyalty or some other critical issues to the business? And so we can kind of build up this capability of thinking about, what represents productivity at different levels and how do we measure that? What's the ultimate way to look at and think about productivity and efficiency? Next, Tracy. So there are flow measures. The critical flow measures typically are cycle time, the amount of work in progress, and the throughput. If you overdo the work in progress, you can really gum up the entire system and slow things down. I mean, every developer knows that you're working on something and somebody drags you off to go fix some problem in some system you worked on last year, and now you're going to be slower getting your critical work done. So the amount of work in progress, and this is something again that comes out of the lean world. You can think of Kanban and some other capabilities, but measuring these becomes fairly critical to understand how efficient a flow is. And then there's a number of measures under that become fairly valuable to understand. What's the waiting time? What's the waiting time at different points in the DevOps pipeline? Am I blocked? What are the blockages? Am I really blocked up in testing because we've got so much built up, and they haven't automated as many test cases as it would really be required to do this efficiently, and so we've got a blockage there, and there's a lot of waiting time sitting there because we haven't made our test process as efficient as it should have been. So we're looking at arrival rates and departure rates. We can look at that both at the overall DevOps pipeline, or we can look at it at subparts of the pipeline where we're looking at bills and testing and a number of other activities. So again, the lean thinking really gives us some strong advantages in looking at measuring productivity, efficiency across this pipeline. Next slide. Now, measuring architecture and its impact on DevOps actually is going to be very critical. I mean, this is the theory. This is a very simplified, oversimplified microservices architecture where I've gone in and I've taken a big monolithic application and broken it into microservices that can be called to provide their particular feature or service. And the nice thing is, if I have to make a change to one of these, it doesn't affect the entire application. I can just make a change to that part because it's really been modularized and it has minimal coupling to the rest of the system, and that's managed through an API. That's the theory. But as the greatest of all American philosophers, Yogi Berra, once said, in theory, theory and practice are the same. In practice, they aren't. So next build. So in reality, this is what an application looks like. This is the connectivity inside, these million line applications, and you'd be amazed how many systems of that size there are out there running businesses. But it's just, it's become a kludge over time. There are some things that are nicely modularized and very cohesive, but then there's just stuff that's connected all over the place. So the first thing we've got to do is figure out, what can I turn into a microservice? I'm not going to be able to microservice probably the entire application. Next build. So I go in and I find these cohesive communities of functionality that would make nice microservices, and I can pull those out and try to, everything goes back to what we knew back in the 70s and 80s about coupling and cohesion. I want a nice cohesive set of functions, and I want it minimal coupling to the rest of the system, and we can pull some of these out very quickly. Others are going to take a lot more study and research. So we're not going to get a microservice architecture from a monolithic architecture overnight. It's going to be an evolving process over time as we're able to find more and more cohesive functions that we can really decouple and turn into a nice microservice. But there's a problem with this. Next build. And that's that there's a lot of complexity in this architecture. As I build microservices, there's a lot more requests for additional functionality and enhancements and fixing bugs and other things. And what we're seeing out there is the degradation of a microservices architecture. People go in and take shortcuts, which creates a lot of technical debt. And they don't use the API. They find it quicker just to go jump in and reference something inside of a microservice, or at least go pull something out of its database without going through the API and the data access routines. And by the time you make a lot of these shortcuts, you've really degraded the microservice architecture. And what that means is the pipeline is going to be slower, because the more coupling you have, the slower things move down the pipeline, because there's so much you've got to evaluate to know that a change you've made to a microservice doesn't blow up something elsewhere in the system. The more we can really modularize, containerize the system, obviously the faster, more efficiently a pipeline will flow. But the more coupling we have, the more shortcuts we take, the more we degrade that efficiency. So we want to be able to look, and we've got to think about how we would measure this at the overall complexity of the architecture, of what portion of that architecture at any given time could be turned into reasonable microservices, what's its microserviceability, if you will, and at the same time, as we continue to update the system and add new functionality and fix bugs, what's the rate of architectural degradation? And that really becomes a governance issue. How do I enforce architectural rules so that we don't see degradation? And what methods do I use, and how do I measure that? What are the impedances in the flow caused by excessive architectural dependency and complexity? Well, how does that impede the flow of things down the pipeline? And what is my potential optimal flow rate if I really had this architecture effectively decoupled into microservices to the extent I could, versus what's my actual situation right now? That'll tell you how efficient you really are with your pipeline. So this is going to require both traditional measures of flow, but also in the case of IT, our software products, it's going to require us to think about the impact of the overall architecture on the product on the efficiency of a DevOps environment. So that's part of what we'll look to incorporate measures of, is these architectural issues that affect the efficiency of a DevOps pipeline. Next slide. So what that has done is really forced us to think about technical debt. And the fellow that was the executive director last year, Dave Norton, executive director of CISQ, pointed out from his years as a Gartner analyst and Gartner consultant that he was seeing enormous amounts of technical debt being built up, especially in agile environments, because the cycle time was so short. People often had to take architectural shortcuts to meet the cycle time limits, and as a result, technical debt was building up in these applications, and the excessive complexity and coupling of architectures is a real problem and really creates enormous amounts of technical debt. So how does that affect us? Next build. I mean, let's think about what the metaphor is here. There's the principle, which is what it's going to cost me to fix a problem. If I've got a weakness that I've got to fix or excessive complexity that I've got to unwind, there's a cost for that. And that's the principle of the debt. There's an interest, which is as long as that's in the system. Let's say I've got excessive complexity, it just takes people longer to do their work, to make a change, to make an enhancement. That's a debt, that excessive effort required to do work. If I'm taking excessive amounts of cycle time because of an inefficient design in the software, it's costing me a lot of money in the cloud, or even on my servers. So the bottom line is that's an interest on the debt until I get the principal retired. So what do those translate into? Next click. I can translate that into some of these measures that we can take from the flow world of, the principle is going to be how much work is in progress, how many things do I have to fix that actually become work in progress that keep me from doing other things, making other enhancements or creating other features. The interest, how is excessive complexity and other kinds of problems going to create blockages, slow my throughput, slow my cycle time, and what have you. So they have direct effects, and we can think about technical debt as a drag on a DevOps pipeline. But beyond that, how does the business think about this? Next click. There is an opportunity cost, which means the more I have to work on eliminating technical debt, the less chance I have to create new features that are valuable to the business. So there's an opportunity cost, and then there's a liability. If I have a major breach, if I have a major outage, if my performance is degrading, then there's a business cost tied to that. We're in the era of 9-digit glitches. These things are now, some of them costing up to $100 million or 100 million euros or more. So that's the enormous risk that some of the worst problems have that come out of some of this technical debt that needs to get fixed. So next click. So we can tie that back to looking at business outcomes and work in progress. So that's those are some of the issues we're going to be deal with in building this framework for DevOps measurement. It's something we'll offer and contribute to the new ISO working group focused on looking at measures in a DevOps environment. But we will create some guidelines, some standards, some measures through OMG related to how we would want to go out measuring in a DevOps environment. So Tracy, put the final slide up again.
Yeah, great. And maybe in the last couple of minutes, a couple questions did come in, and then I'll be posting Bill's slides here into the chat box so everyone can take a copy. Bill, one of the biggest challenges are the use of story points by teams and no normalization to evaluate one team to another. How are the DevOps measures intended to inform the organization, i.e. by team, by project, by organization, et cetera?
Yeah, well, and you just really crystallize a massive problem. I mean, one of the problems with Agile is it was a team-based approach. It was a tribal approach. It never really had mechanisms for organizational level measures, organizational level learning. Most learning was done in retrospectives at the team level. And so, but once we have a DevOps pipeline, that suddenly becomes a more standard way of looking at development, and it's going to force us to take measures that are driven by the structure of our pipeline and the structure of work flowing down it, which is why I say I believe a lot of Agile is going to be consumed in DevOps. And that will force us to use more common measures, have more common measures of the size of things moving down the pipeline, of the productivity within that, and allow us to look in a more common way at productivity, at quality, and other kinds of mechanisms than we would face if we just were using storage points, which really aren't standardized across the organization.